All right, thank you very much for coming. It's always fun to come here and lecture to you. I was here maybe 2 or 3 years ago giving this lecture. Who was in my talk back then? Anyone, or is it a completely new group of people? Completely new, huh? Very good. I just want to make sure because I'm going to repeat some of my bad jokes, you know. So that's about me. Now, actually a bit more about me. So I grew up in Copenhagen, Denmark. We got one from Germany. Anybody else from, anyone from Denmark? Denmark. Snakker du dansk?
Ja.
Oh, er det rigtigt? Oh, perfect. But I'm Danish. So I'm Danish. My parents are actually Kurdish from Iraq, and I brought my dad today, as you can see. So I'm Kurdish from Iraq. My parents came to Bulgaria. They lived in Bulgaria for a little while. And then we came to Denmark as refugees. So I lived in a little refugee camp. Do you know Sandholm? So I lived there for a little bit. I was a baby, and then I grew up in Copenhagen, went on to study at various places, lived in Egypt for a bit, then in California, worked with V.S. Ramachandran, a neuroscientist over there, went to Cambridge, did some work at Harvard, and so forth and so on. But when I was a teenager, something very striking happened. I was sleeping in my bed, you know, and I suddenly realized, my God, I can't actually move, I can't speak. Really weird, right? But I felt like I was awake. Like I felt like I could see my room and my surroundings, and I felt like, okay, what's going on, right? So, and at that point I thought, okay, maybe I'm dying, maybe I'm paralyzed or something like that. And I started to scream like, Dad, Mom, but nothing could come out, all right? And then I had this feeling of this ominous, vicious creature in my bedroom. Okay, and this feeling got stronger and stronger until I felt like something was actually pressing on my chest, like literally like something really heavy on my chest and then strangling me. And then I saw my legs flying up and down, like that, you know? And I thought, now I'm gonna die. Now it's over, okay? There's something like an ominous demon here in my room trying to kill me. But luckily I did wake up, and the next day I didn't know what to do. Like, do I go tell my parents? There was a ghost in my room. The ghost tried to kill me. By the way, in high school, I was the worst student you can imagine. Like, I was just like, I had really bad grades, didn't do well at all. And so I didn't have a good track record either. So I couldn't go to friends, you know, say that I'm seeing ghosts and stuff. It wouldn't fit the mold, right? So it would be quite odd. But I got interested in this phenomenon called sleep paralysis. This is actually an episode of sleep paralysis. A very curious, fascinating phenomenon. And I'm going to argue in this talk that sleep paralysis might be the most fascinating, most striking phenomenon in the entirety of medicine. Now, before we go into sleep paralysis, we have to discuss and talk about REM sleep. And actually, what sleep is, the symphony of sleep. And we have to talk about what's going on in the brain a little bit during sleep paralysis, why your brain would make you see these ghost-like creatures and feel like these presents are, you know, these beings are present. What's going on in the brain? So we have some ideas for that. And then I'll talk about my work on sleep paralysis around the world, which is quite interesting as well. But first of all, I'd love to emphasize, and I do this all the time, we all have a sense of self, a sense of I, a sense of me. Okay, I feel like I occupy Balan's body, right? I feel anchored firmly in this body. I don't feel like I occupy Manaf's body, right? There's this clear separation between you and I, right? But there's actually a part of the brain called the temporoparietal junction or the superior parietal lobule. Fancy names for, clusters of cell structures up in that region of the brain. And that region of the brain is critical because it pulls information from various sensory modalities. So you have vision, you have the temporal lobes, right? You have various, parts of the brain that are important that have various tasks, And so that part of the brain, in red up there, pulls that information from the vision part of the brain, from the hearing part of the brain, from the tactile part of the brain, and then merges all that and creates a sense of self and sense of Manaf or Balan. So I feel firmly anchored in my body. Is that clear? So that's why that feeling. Actually, we know in phantom limbs, do you know what phantom limbs are? So phantom limbs is a very interesting phenomenon. So people that, they are driving in a car, get into an accident, and then they have to amputate their arm. In many cases, they will feel like an arm is present even though the arm is gone, the physical arm is gone. And that's because that body image, that sense of self is still being processed. It's still present, and that's why you have that sensation. That's clear, right? Very good. Oh yeah, thank you, Aljo. Appreciate it. Now, okay, that was good. Thank you. All right, so if that part of the brain is damaged, okay, strange things will happen. So if somebody, for example, has a stroke in that part of the brain and their left arm is paralyzed, they will still be normal in other respects. You sit down with them, you play chess with them, okay? They go on Facebook, on YouTube. Everything is normal, all right? But they have one quirk. They might attribute their arm to the doctor now. They will say, doctor, this arm doesn't belong to me anymore. It belongs to you. So there's a breakdown in self-attribution of limbs, right? This arm is supposed to belong to me, not to the doctor, right? But because these parts of the brain are so crucial in giving us that personal feeling of a sense of an I, and if those parts of the brain go awry, we'll see that you literally start saying, my arm belongs to Johannes, right? Or Ruben, for example, right? So that's not a good idea. So we don't want that. In fact, if I was to temporarily disrupt that region of the brain, let's say I was to take an electrical current and zap that part of the brain, you will feel like, there's a ghost like double of you hovering over you. Okay, so we can make you into a ghost by just zapping that part of the brain. So it shows you how crucial it is in creating a sense of I, a sense of a self. Okay, so let me take you back to sleep. And so on my way here, I was chatting with my dad. It was very nice. I'm sure you love having conversations with your parents. So we were chatting on, the bus and the train here, and my dad said, look, can you tell me about sleep? What are the stages of sleep? And what is this REM sleep you keep talking about? Like REM, what the hell is REM, right? So I said, look, Dad, let me take you through the stages of sleep, because we all cycle through these 90-minute cycles of various unique stages, right? And we have about 4 of these throughout the night, assuming you sleep 8 hours. You do sleep 8 hours, right? Okay. Okay. So we cycle through these stages, and each stage is quite peculiar. So during stages 1 and 2, as you can imagine, the body relaxes, right? Body temperature drops, it cools down, your heart rate, your blood pressure kind of goes down, right? And if you look at the brain activity of somebody who's kind of in that state, the brain starts calming down, right? Just becoming calmer and calmer. And then suddenly, the brain changes and goes into this weird state called slow wave sleep or deep sleep, where the brain, the activity of the neurons in the cortex go like this, really strange, up and down. You can see it's almost like a window cleaner because there's so much cleaning going on in the brain, right? At this point, the brain engages in various housekeeping chores, all right? So it will your cells will shrink, your neurons will shrink, allowing cerebral spinal fluid to bathe the brain to clean it up all the toxins and stuff that have built up pretty much during the day, right? Some beta amyloid and various misfolded proteins that can aggregate over time and lead to things like Alzheimer's and stuff like that, right? So you have this cleaning system, and your body secretes hormones and repairs your cells. So there's all this stuff going on, very interesting. Your memories are being consolidated, so your brain starts consolidating all the stuff you did during the day and sees what it can use and how to sort of strengthen certain circuits. And so you can see how important this stage of sleep is, this deep sleep. And during the night, it turns out we have more of this deep sleep early in the night. So these 90-minute cycles, these blocks, right, 90, 90, 90, during the first few 90-minute cycles, you have more of deep sleep and less of REM. So the brain prioritizes your physical well-being. Okay, good. Then we enter into REM sleep. And here the funny stuff happens. It's very, very, very interesting here. Now, during REM, the brain, first of all, what it does is you see the activity of somebody in REM sleep suddenly becomes active. And the brain, if you eavesdrop on the activity of neurons, the person who is in REM now looks like he was when he was awake. In fact, if you listen well enough, the guy in REM looks more awake than the guy, who's actually awake. Okay, so you have these waves going like this now, really, really fast, right? And the heart rate, starts becoming elevated. Blood pressure becomes elevated. So you have all this stuff going on. Very, very interesting now. You wouldn't expect that. Look, before REM sleep was discovered, if you told a scientist, you have this, stage of sleep where you are, you look so active, the brain looks like it's, it's on steroids, people wouldn't believe you, They thought sleep was just about relaxing the brain. So it's quite curious you have this stage of sleep. But more than that, there's sort of an interesting switch in the neurochemical environment as well, right? So what you see is that the neurons called serotonin-producing neurons and noradrenaline-producing neurons stop firing altogether during REM. Now, why am I telling you this? Well, you need these neurochemicals for very important tasks, and especially the CEO of the brain, okay, the cortex, the cortical regions of the brain that are heavily active during the day. Those regions really needs these neurotransmitters to keep things in order. Like a CEO needs its information and it needs its fuel. This is the same thing. You need to have these neurochemicals. At the same time, you have another neurochemical called acetylcholine, which is ramped up, and that makes the emotional part of the brain, the instinctual emotional part of the brain, the limbic structures hyperactive. Okay? This starts to make sense now because we have dreams during REM sleep. Okay, so we have dreams during REM, and dreams during REM are heavily emotional. They're instinctual, right? And you sort of lack the ability to control your emotions. Well, then that makes sense when you think about the neurochemical environment, but we'll get more into this. So, what is these cortical regions important for? First of all, you have a sense of logic. We all have a sense of logic, right? I construct a reality for myself, right? So I'll say Beland is here giving a lecture, okay? There's a wall, there's a picture of a handsome gentleman up there, okay? This guy, there's all these things, and I construct a reality for myself, right? And I need a part of the brain called the dorsolateral prefrontal cortex. Let me see if I can. You need a region called the DLPVC, a region important for logic, for putting things together in a meaningful, cohesive way. You need that in order to navigate the world when you're awake. But during REM sleep, that part of the brain is not working, it's turns off. And so for that reason, things are messed up. That's why, reality is sort of blended. Things are mixed, things are messy. And that's a reason for that. And then the part of the brain that has to do with our sense of body image. I told you need those structures back up in the brain in the TPJ regions. You need those regions to create a sense of self. But it turns out during REM sleep, during dreams, that part of the brain sort of turns off. And so the self becomes loosened up. Okay? The self is no longer as anchored to the body as it should be, all right? And that's why you sometimes feel like, you feel anchored in your body, you have that first person perspective, I'm seeing the world, I'm looking at my hands like this, I'm communicating with you guys, okay? But occasionally, you see yourself like a Netflix movie up there, looking down at yourself, right? So you have that perspective. Or sometimes you feel like you occupy somebody else's body. You might feel like you're occupying Shakespeare or Napoleon's body. Who's ever had that before? Have you ever seen yourself occupy somebody else's body in dreams? Okay, so we have a few examples, right? So the sense of self is loosened up. The self is no longer as anchored to your physical body. So those are examples of things. What about memory? Do you remember your dreams? You remember your dreams? How well do you remember your dreams? Well, it turns out 95% of dreams, Eljo, 95% of dreams are, not remembered at all. So what we do remember occasionally is about the last part of the last cycle of REM. So if you have all these blocks of sleep cycles of 90 minutes, you go boom, 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 boom. What you remember is like the final fragment of the final portion, like the few last minutes. But you've slept during all these stages of REM sleep. And perhaps you also you dreamt during these REM stages, and perhaps also in some of the other stages as well. We also dream a little bit in the other stages of sleep. But REM is where you have those really interesting, bizarre, lifelike dreams. So you have that little bit of memory, and usually your brain makes you forget that by the time you have lunch, right? So you forget your dreams really fast. So what's going on there? My dad asked me, he said, look, Baland, how come why do we forget our dreams? What's going on? So I said, look, Dad, it turns out a part of the brain, the hippocampus, I'm sure you all know, it needs sort of serotonin to work and store memories, and it shuts off during REM, so you can't really remember your dreams very well. But he said he didn't buy that. He said, look, Balan, that can't be right. That can't be right. And I said, building suspense a little bit. I said, no, you're right. There's got to be some underlying logic for your brain to do that, right? So there's got to be some. So it seems like, and this is one idea, that your brain is purposely inhibiting your access to dreams. So that's one idea, that your brain says, look, buddy, it's probably not a very good idea for you to remember your dreams, because dreams are so intense. They're so personally salient and powerfully profound. If you remember all these hours of bizarre, illogical entertainment from each night, you'd probably go mad, right? So your brain maybe has this mechanism to inhibit those dream memories. And in fact, some people say, and some people argue, scientists would say, maybe we have different circuits in the brain to store, for storing memories of dreams and memories of somebody who's wakeful memories, normal memories. But you think about it, that's a good question, right? How does your brain differentiate between dream memories and lifelike memories? But it seems like there are certain different circuits, perhaps. It's an argument, which makes a lot of sense, because it's a very profound experience. And so one idea as well is that, look, the chemical environment with the serotonin neurotransmitter activity going down, what you might see is an activation of other receptors of serotonin, like serotonin 2A. And I'm not trying to be overly technical here, but I'm saying this serotonin 2A receptor is important for those for when you take hallucinogenics like psilocybin, LSD and stuff, you really activate, you tickle those receptors. And that's why you have these bizarre experiences where you sort of look at a wall and say, oh my God, this wall is profound and meaningful, You shouldn't do that, right? You shouldn't look at a wall and say, this is too, but that's what dreams are like. I have people contact me and say, oh my dreams are so meaningful. I was walking and then I saw, the sun and the moon and the stars were dancing, and that's what people will say. You have these profound metaphors and visual images, right? This imagery. But it's more important for you than the rest of the world. And that's what I'm saying. There seems like to be a personal salience, personal thing about the dream for you. And those are the circuits I'm talking about. And I'll make another argument, and this is something I will probably write in future books and stuff, just to claim, the idea for myself, is, have you had that dream where you sort of, you have a dream, it's very interesting, it's very funny, it's powerful and stuff, and then you forget the dream. But then you're in another dream 3 weeks later and you go, my God, I remember that other dream. Isn't that funny? But that is another hint that your brain is then reactivating those circuits that has to do with dream memory. Those syrups, those kind of salient circuits, I call them, just for fun, right? Those circuits are activated. And some even go one step further and say, when you go to Oxford for the first time in your life, you've never been here, you go and then you see one of these castles or something, and you go, my God, I've been here before. Well, I remember this. It's called déjà vu, right? Some argue that déjà vu is actually just an activation of those circuits while you're awake. And that's why when you go and say, oh, I've been here before, maybe it's in another life, maybe it's something else, it could be that you're activating those circuits, and that's why it has this cosmic flavor to it. It's not merely just remembering something. It's not like, I've been here. It's like, oh, I've been here. It's like, you know what I mean? It has that, cosmic meaning to it. And then my conversation with my dad was also, so tell me more about these dreams and unrelated things, because it tends to be things that are deeply unrelated, my dad said. You agree, right? It's in dreams you see yourself on the moon in a suit, having tea with the queen, and then the things are rotating, and then you're playing for Liverpool next to Mo Salah and stuff, right? It's bizarre. And so why all these things, right? But it seems like what your brain is doing is almost like a visual poet. And so it takes these ideas and concepts that it cannot convey using language, semantics. It cannot say, look, Baland, you're now doing this or that, It needs like a strong, powerful, profound metaphor, something visual, and shows that to you. And it has this, preference towards things that are unrelated, okay? Meaning, if I, was to wake Ruben up during REM sleep, and you're dreaming, and I wake you up, and I say, look, Ruben, tell me what words are related, and I show two words, like thin and thick, right? You say, okay, during wakefulness, we tend to, connect these words fast, but somebody who's woken up from REM will connect things that are unrelated, so they'll be much faster at saying thick and sun instead of thick and thin. Is that clear? So that's been shown in experiments. So it shows you have this, this inclination towards relating, things in the world that's unrelated in that way. That's very interesting. How long is the talk, by the way? So dreams during REM sleep tend to be populated by people. That's another theme. I told my dad, said, look, there's a lot of people in your dreams, right? And again, what's going on there? Why would you have all these people in your dreams? Well, it turns out we have a structure in the brain, around the same regions where I showed you before, in the TPJ region up here, remember I showed you? In that part of the brain, you differentiate between self and other. You go, okay, this is me, this is Baland, this is Manaf. Manaf is thinking these thoughts right now. This is his, logic right now. This is his agenda right now. And of course, by me creating a theory of mind around, you and your thoughts, that allows me better to sort of survive. That's a good survival thing to have that theory of mind. In fact, in some disorders, that ability goes down, and then you don't have that ability as much to sort of guess what, Johannes or Ruben is thinking right now. That goes away a little bit, right? But that's a very good thing. And it seems like during REM sleep, you create all these human beings, these people, and interact with them in order for you to sort of update the sense of self, the sense of I. In relation to other people, sort of reading their minds, oh, this is a serial killer, let me run, okay? This is a girl, let me talk to her, okay? You have all these things. And actually it tends to be more negative, actually. So your brain during REM and these dreams has a tendency to create more negative scenarios. And that makes sense too, because that's more survival, better for your survival. To navigate a world that's dangerous in your dream, and strengthening circuits related to those things makes you more likely to survive versus just being on Hawaii and chilling. You know what I mean? Okay. So you have all that. So it tends to be around the self. The sense of I is being constructed, and it's a big theme. During dreams, it's often about the self. And yeah, I just wanted to add one more thing. This tends to be the environment you're in. It's funny because the environment feels familiar. You feel like you know the environment. It might be your room, so you go, this is my room, this is my bedroom, but little do you know, it's actually like Buckingham Palace or like a castle from 500 years ago. But you feel like this is actually my room. So there's a sense of a novel environment, or actually there is a novel environment that feels familiar and feels like home. Okay? Again, those circuits of personal, things feels personal and profound, and you say, oh, this is normal, but it's not. And then there's time perception as well. I want to add to that a little bit, talk about that. Are dreams slowed down, compared to reality? How is the sensation of reality, of time in dreams? So V.S. Ramachandran, a colleague of mine in UC San Diego, were thinking about that. We said, look, how do you process time in dreams? So for example, if you have a guy, like we have Eljo, we bring him to the laboratory and we have him lay down. Eljo is lying there. And then, we make sure that Eljo is now in REM, okay? He's sleeping in REM sleep. Then what I'll do is, Eljo, I will sprinkle water on you, like this, okay, and then wake you up instantaneously, all right? Now imagine if Eljo is now during that time was in his dream, and he was dreaming that he was walking on Oxford. It was sunny, right? And then suddenly, the water came. Now this is actually, before I go into that, we can infiltrate dreams, that's known. Do you know that? So by stimulating somebody who's outside, like who's dreaming, and then you sprinkle water, you should be able to infiltrate his dream. That's well known, okay? Coming back to the experiment. I'm sprinkling water on El Joe, and then I wake El Joe up, right? Will he have time to incorporate that water into his dream? Would that be possible? All right. Will he go, I was walking, and then I saw the clouds, it became darker, and then I took out my phone. I said, look, I have to remember, to do this and that, and then it started to slowly rain, and then it started pouring. Okay? Or will he just go and there's a tsunami that hits him, when he wakes up? Right. So this is an experiment we've been thinking about, and one day at Harvard, I said, let me talk to, and this was after I had a conversation with another colleague of mine, Richard McNally, about like how dreams really can be infiltrated by outside sources, as I was saying, forces. Like if you're in a cold room, you feel like you're in a cold environment, like on Greenland, chatting with an ice bear or something. Could happen in a dream, right? So you have that. You can infiltrate your dreams like that. You can influence them, and the environment can influence your dreams. So we thought about this experiment, and so talking to Richard McNally, I said, let me talk to Hobson about it, Alan Hobson. Do you know Alan Hobson by any chance? So Alan Hobson, I was fortunate to know him a little bit at Harvard. He was probably the greatest dream researcher after Freud. He was really, really big guy in the field, and I'm just saying this to brag, by the way. No, I was actually, there's something coming, So I said, Hobson, we have this experiment with Ramachandran, my colleague in San Diego. We want to sort of look at dreams. I said, that sounds interesting, Balan, but you have one problem. I said, what? Like, what's the problem? Why can't we do this experiment? Well, I said, remember, you're paralyzed during REM sleep. So it turns out during REM sleep, we're all paralyzed from head to toe. It's one of the features of REM. Okay, so that makes sense because you don't want to act out your dreams and hurt your sleeping partner. You know what I mean? Like I don't want to go in my hotel and sleep and then hurt my dad or something, or shout. So you don't want that. So your brain is clever. It says, look, buddy, let me paralyze you during REM sleep. So you're paralyzed. But here's the thing: if you sprinkle water on somebody, and this was the professor's point, if you sprinkle water on somebody while he's in REM, then you're gonna what? You might wake him up, right? That's the problem, because you have this interesting, you're on a knife edge. Too much stimulation, you wake the poor guy up. That's why if you shout at somebody who's sleeping, what's going to happen? He's going to wake up, right? Same with water. So if you just sprinkle a little bit, he's going to wake up before he can sort of